Hello there, and welcome to Science for Sleep. Tonight, we will journey far beyond the familiar glow of our own Milky Way and drift into the boundless dark of intergalactic space to visit one of the most majestic neighbors in the universe, the Andromeda Galaxy. To the naked eye, Andromeda appears as nothing more than a faint, ghostly blur hovering in the night sky, a soft patch of mist among the stars. Yet what we are actually seeing is a colossal spiral system containing more than 1 trillion suns, each one shining with its own story and light. Its arms extend across hundreds of thousands of light-years, curving gracefully through the black sea of space, glowing softly with the blended radiance of uncountable stars. The light that reaches our eyes tonight began its journey more than 2 million years ago, long before the first humans walked upon the Earth. Long before the fires of early civilizations flickered in the dark. Every glimmer from Andromeda carries with it the tale of distant suns, of clouds of dust where stars are born, and of worlds that no one may ever set foot upon. Deep within its spiraling arms, stars are continuously being created, colliding, and fading away, recycling the raw materials of existence into endless new forms. Andromeda is not just another twinkle in the heavens. It is our nearest great galactic companion, drifting ever closer to us through the cosmic void. In billions of years, its fate and ours will intertwine, as it merges with our own Milky Way to create something entirely new, a vast elliptical galaxy that will shine as one. For now, though, you can simply relax and breathe, letting your mind soften as we travel together through time and space. The Andromeda Galaxy, also known as M31, stands as the nearest large spiral galaxy to our own. Among the countless galaxies scattered like islands across the universe, Andromeda is our closest spiral neighbor, lying a mere 2.5 million light-years away, an almost unimaginable distance by human standards, yet a short reach on the cosmic scale. This proximity offers astronomers a rare gift, the chance to study a galaxy very similar to our own from an external vantage point. Through Andromeda, scientists can glimpse the structure and life cycle of a system like ours, how stars form, how dust and gas move, how galaxies evolve through time. When seen through powerful telescopes, Andromeda's structure becomes breathtakingly clear. Its glowing disk stretches across the darkness, its delicate lanes of dust weaving through glowing rivers of starlight that spiral toward a luminous central bulge. Every photograph captures the same sense of cosmic order we find in the Milky Way, yet on an even grander, more intricate scale. In this way, Andromeda serves as a mirror, reflecting not only light but also understanding, showing us what our own home might look like to distant observers scattered across the cosmos. Its closeness has made it one of the most carefully examined and deeply studied objects in all of astronomy, a living example of how galaxies grow, interact, and change through eons. In the calm, silver light of Andromeda, humanity can see both its cosmic neighbor and a preview of its own distant destiny, written across the sky in radiant spirals of time. Within Andromeda's immense, glittering body lie approximately 1 trillion stars, each burning with a unique color, temperature, and rhythm. From the densely packed heart of ancient suns near its center to the sweeping arms that stretch outward into the silent void, these stars fill every region with life and motion. Some are enormous, blue-white giants that live short, brilliant lives, shining fiercely before dying in spectacular explosions that scatter heavy elements, the seeds of planets and life, into surrounding space. Others are small, dim red dwarfs, quietly glowing for trillions of years, outlasting the galaxies themselves. Together, they weave a luminous tapestry that can be seen across millions of light-years, their collective brilliance so vast that, on a clear and moonless night, even the unaided human eye can detect it. When you stand beneath the dark sky far from city lights and look carefully toward the constellation Andromeda, you may notice a faint smudge of light. That faintness is deceptive. What appears as a tiny mist to us is the combined light of more than 1 trillion stars shining through the depths of space. To the ancient sky watchers, it was a mystery, a glowing cloud that neither moved like a planet nor twinkled like a star. They gave it mythic associations, believing it to be something ethereal and distant. It was not until telescopes were invented that humanity began to see the truth. The Andromeda Nebula, as it was once called, was not a mere cloud of gas but an entire galaxy of unimaginable scale, a whole island universe beyond our own. For centuries, even the most advanced astronomers believed that Andromeda was part of the Milky Way, a nebula within our galactic bounds. Early telescopes showed only a dim patch of light, which they assumed to be a local gas cloud or cluster. It was catalogued among other so-called nebulae, its true nature hidden by the limits of our instruments. That view persisted until the early 20th century, when the pioneering astronomer Edwin Hubble turned the 100-inch telescope at Mount Wilson Observatory toward Andromeda and made a discovery that changed humanity's understanding of the universe forever. Within the hazy glow, he identified a type of pulsating star called a Cepheid variable, a star whose rhythmic brightening and dimming reveals its distance. When Hubble calculated how far away these stars truly were, he realized they lay millions of light-years beyond the Milky Way. Andromeda, he concluded, was not a small cloud inside our galaxy but a separate galaxy entirely, another immense collection of stars, gas, and dust like our own. This revelation shattered the boundaries of the known universe. Suddenly, humanity understood that the cosmos extended far beyond the Milky Way, filled with billions of galaxies scattered across unimaginable expanses. The Andromeda Nebula became the Andromeda Galaxy, and our place in the universe grew infinitely larger. When we gaze at Andromeda today, we are looking into the past, a glimpse of light that began its journey long before human civilization existed. Every photon that strikes our eyes tonight has been traveling for more than 2 million years, crossing the silent intergalactic void. Many of the stars that emitted that light may have long since changed, some having exhausted their fuel, others having exploded into supernovae, leaving behind white dwarfs, neutron stars, or black holes. Yet their light continues to stream onward, undisturbed by time, carrying with it a record of what once was. Observing Andromeda, then, is not merely a scientific act, it is a communion with the deep past. The light now entering our telescopes began its journey when the earliest ancestors of modern humans walked the plains of Africa, crafting stone tools and watching distant fires. To see Andromeda is to touch time itself, to receive a message from across ages, carried by waves of light that have crossed the gulf no living thing could ever traverse. Despite its serene appearance, Andromeda is not still. It is moving, and not away from us, but toward us. Astronomers studying the color of its starlight discovered a subtle shift toward the blue end of the spectrum, a sign that the galaxy is approaching rather than receding. This blue shift is unusual, because nearly all other galaxies are moving away from us as the universe expands. Andromeda, however, is being drawn closer by the mutual pull of gravity between our galaxies, racing toward the Milky Way at a speed of over 200 kilometers per second. Though this motion is invisible to the naked eye, it is unstoppable. Every second brings Andromeda imperceptibly nearer, its vast form gliding across the dark fabric of space. This slow approach, this cosmic dance of attraction, is a quiet reminder of the forces that shape the universe. Nothing can halt it. It has been written into the motion of space itself since long before our planet was born. Through decades of careful observation, astronomers have mapped this collision course in astonishing detail. Using data from space observatories like the Hubble Space Telescope and the Gaia mission, scientists have measured Andromeda's trajectory and motion across the sky with great precision. Their findings reveal that the galaxy is not simply passing by, it is heading directly toward us. Computer simulations have traced this encounter billions of years into the future, showing that the two galaxies will first draw near in about 4 billion years. When that happens, the night skies of any surviving Earth-like worlds will change dramatically. The vast spiral arms of Andromeda will stretch across the horizon, glowing like ribbons of fire against the blackness. Over the course of another few billion years, the two galaxies will slowly merge, their stars swirling together under gravity's command, forming long, luminous tails and tidal streams that sweep across space. It will not be a violent collision. Galaxies are mostly empty space, and the stars within them are so far apart that direct impacts between suns will be exceedingly rare. Instead, the two systems will gently blend, their shapes distorted, their centers pulled together until they eventually form a single, enormous elliptical galaxy that astronomers have already named Milkomeda. In this future galaxy, the night sky will be breathtaking. From any planet that survives the transition, the heavens will blaze with hundreds of billions of nearby stars. The combined light of the two galaxies will fill the darkness with a golden glow. Over time, the chaotic motions of merging stars will settle, gas clouds will ignite with new star formation, and the cores of both galaxies, each housing a supermassive black hole, will drift together and eventually merge, releasing titanic bursts of energy in gravitational waves. The process will take billions of years to complete, a slow and graceful blending rather than an explosion. Though it may sound dramatic, the event will be silent and beautiful, a cosmic waltz performed over unimaginable spans of time. Our solar system, by then, may have changed beyond recognition. The Sun will likely have exhausted its fuel and transformed into a white dwarf, and Earth may no longer exist as we know it. Yet the stars born from the gas and dust of both galaxies will carry forward the legacy of our corner of the cosmos, shining in new constellations under new skies. When we consider all this, the immense distances, the ages of light, the future collision already unfolding in slow motion, Andromeda becomes more than just a distant object of study. It becomes a symbol of the interconnectedness of all things, of the grand cycles of creation and transformation that define the universe. The same forces that shaped our galaxy are at work there too, weaving the same cosmic patterns on a larger scale. When you look up at Andromeda on a clear night, you are witnessing one of the greatest relationships in the cosmos, the quiet, inevitable meeting of two galaxies bound by gravity and time. It reminds us that nothing in the universe is truly static. Everything moves, evolves, and changes. Even galaxies dance, drift, and merge in an endless rhythm. And so, as you rest beneath the stars tonight, imagine the slow movement of Andromeda toward us, the faint glow in the night sky that carries the light of a trillion suns and the memory of ancient times. Think of the distance that light has traveled, the generations that have looked upon it before you, and the infinite space that lies between. Let that vastness fill you not with fear but with calm, for in the great stillness of the cosmos, there is peace. The universe moves at its own patient pace, writing its stories across billions of years, while we, for a brief moment, are lucky enough to look up and see. Close your eyes and let your mind drift among the stars, carried by the soft light of Andromeda, our neighbor, our mirror, and our future companion in the eternal night. Their spiral arms will one day twist and stretch into vast rivers of starlight as gravity slowly pulls the Milky Way and Andromeda together in a dance that has already begun. Across billions of years, these two magnificent spiral galaxies will drift closer and closer, drawn by the invisible threads of gravity, their luminous disks rippling like silk in a cosmic breeze. Though the sheer number of stars within each galaxy is beyond counting, the space between them is so immense that most will never collide directly. Instead, they will glide past one another, reshaping their paths into new orbits within a vast and growing system. Over the passage of time, their once distinct shapes will blur and blend until the two galaxies become one, an enormous elliptical galaxy glowing with a bright, concentrated core surrounded by vast, diffuse edges of light. From any surviving world orbiting a distant star, the sky will blaze with radiance as billions of suns from both systems mingle across the heavens. This merging will mark a new chapter in the story of the cosmos, transforming two graceful spirals into one enduring whole that will continue to shine long after the Milky Way's familiar shape has faded. Astronomers have already named this future galaxy Milkomeda, a poetic fusion of the names Milky Way and Andromeda, symbolizing the shared legacy of both systems. It is expected to contain several trillion stars, stretching across hundreds of thousands of light years, a monument to gravity's patient artistry. At its very heart, the supermassive black holes that currently rest at the centers of each galaxy will slowly spiral inward toward each other, circling ever closer in a titanic dance that will end in their merger, releasing an unimaginable burst of gravitational energy that will ripple across space-time. To distant observers, Milkomeda will appear as a smooth, rounded galaxy with a brilliant golden core, calm and symmetrical, glowing as a reminder of the two great spirals that once faced each other across the night. Within its light will lie the merged history of both galaxies, every star a record of their shared journey through time, and every orbit a trace of the cosmic embrace that shaped them. It is a quiet reminder that even in the vast stillness of space, nothing remains unchanged forever. The Andromeda Galaxy itself is a colossal spiral, one of the largest of its kind ever measured, stretching more than 200,000 light-years from edge to edge. Its arms, luminous with the light of newborn stars, wind outward from a bright central bulge, weaving lanes of dust and gas that trace the geometry of cosmic motion. These arms are not solid structures frozen in time, but moving waves of density, like ripples traveling through water, compressing the gas they encounter and triggering bursts of star formation as they pass. In their wake, clusters of hot, young, blue stars flare into existence, their light blazing briefly before fading into the background glow. Between these shining bands lie darker regions where thick clouds of interstellar dust absorb and scatter starlight, lending Andromeda its textured appearance. Through powerful telescopes, astronomers can watch how these patterns shift over millions of years, revealing the constant flow of matter as it collapses, disperses, and reforms in an endless cycle. This delicate balance of order and chaos within the spirals tells the story of a galaxy alive with motion, forever reshaped by the gravitational forces that both bind it and drive its evolution. Andromeda dwarfs our Milky Way in size, standing as one of the true giants of the local universe. When viewed through a telescope, its vastness becomes difficult to comprehend. Its sprawling disk stretches more than 220,000 light-years from end to end, nearly twice the diameter of our own galaxy, and contains well over 1 trillion stars. Surrounding this immense system is a faint, ghostly halo of stars and dark matter that extends even farther, gradually fading into the intergalactic void. If human eyes could perceive the full extent of Andromeda's glow, it would appear several times wider than the moon in the night sky, a vast celestial swirl hanging quietly above us. This scale reminds us that galaxies are not tidy pinwheels of light, but sprawling cosmic cities composed of stars, nebulae, star clusters, and immense clouds of invisible matter. Compared to Andromeda, our Milky Way feels like a younger sibling, orbiting within the same galactic family, both bound by gravity and destined to meet in a magnificent union that will echo across time. At the center of Andromeda lies a radiant core glowing with the combined light of billions of ancient suns. The glow is warm and golden, created by stars that have burned steadily for billions of years. Most of these stars are smaller and older than our Sun, their fuel slowly depleting as they drift toward the end of their lives. In this crowded hub, stars are packed so densely that in some regions they are separated by only fractions of a light-year. The light from this central region travels for over 2 million years before it reaches our telescopes, bringing with it the ancient history of a galaxy that has seen ages rise and fall. The golden hue of Andromeda's core reveals that its population of stars is old. The frantic birth of new stars has slowed here, leaving a calm and enduring glow that acts as a fossil of the galaxy's youth. This core is not only a relic of its beginnings but also the seat of its greatest mystery, the presence of a supermassive black hole. Astronomers studying the motion of stars near Andromeda's center have observed them whipping around an invisible point at astonishing speeds, an observation that can only be explained by the presence of an object millions of times more massive than the Sun. This supermassive black hole, hidden within the golden heart of the galaxy, exerts a gravitational influence so strong that even light cannot escape once it crosses its event horizon. Around it, stars dance in intricate, high-speed orbits, a gravitational ballet that has been unfolding for billions of years. Nearby, swirling disks of superheated gas and dust emit brilliant radiation as they spiral inward, feeding the black hole's appetite. Though the black hole itself cannot be seen, its presence is known through the way it shapes the behavior of everything around it. It is the silent engine of gravity that governs the rhythm of Andromeda's heart. Yet, as astronomers have looked closer with ever more precise instruments, they have discovered something even more intriguing. The light from the core does not come from a single bright point, but from two. This has led scientists to theorize that Andromeda may contain not one, but two supermassive black holes orbiting one another deep within its center. If true, this would be evidence of a galactic merger long past, an ancient collision between two galaxies whose cores have not yet completely merged. Over time, these two invisible titans would spiral closer together, releasing ripples of gravitational energy that travel through the very fabric of space-time. Eventually, they may merge into one even larger black hole, their union marking the end of a process that began billions of years ago. This hidden dance mirrors the destiny of our own galaxy, for at the core of the Milky Way lies its own supermassive black hole, Sagittarius A*, which may one day merge with Andromeda's central black hole when the galaxies themselves unite. The idea that such colossal forces lie hidden within quiet patches of light is both humbling and awe-inspiring. Beyond the glowing core and the bright spiral arms lies an even greater mystery: Andromeda's halo, an enormous, invisible sphere surrounding the galaxy. This halo extends more than 1,000,000 light-years from Andromeda's center, making it several times larger than the visible disk. Composed of diffuse gas, scattered dust, and vast amounts of dark matter, it cannot be seen with human eyes, yet its influence shapes everything within the galaxy. Within this faint sphere drift ancient globular clusters and long streams of stars, remnants of smaller galaxies that Andromeda absorbed long ago. Scientists study the halo using ultraviolet and X-ray telescopes, tracing the faint signatures of atoms energized by distant starlight. Though it appears ethereal, the halo is crucial to Andromeda's structure, acting as both a boundary and a reservoir of matter from which new stars may one day form. It is, in essence, the galaxy's unseen aura, blending gradually into the intergalactic medium that fills the spaces between galaxies. Perhaps the most extraordinary revelation about this halo is that it may already be touching our own. The Milky Way and Andromeda, though separated by more than 2,000,000 light-years of apparent emptiness, are not as isolated as they seem. Observations suggest that their vast, invisible halos overlap, meaning that the two galaxies are already in contact, not through visible stars, but through delicate streams of hot plasma and dark matter. In a sense, the merging has already begun. Long before the luminous cores meet, the invisible atmospheres of both galaxies are exchanging matter and energy, mingling in ways we cannot yet fully perceive. This realization changes the way we imagine the cosmos. It reminds us that the boundaries between galaxies are not rigid lines but gradual transitions, like the blending of colors in a sunset. The universe is a web of connectedness, where even the emptiest regions of space hum with interaction. Andromeda's disk itself is not perfectly flat. When astronomers mapped its stars and clouds of gas, they discovered that it bends and twists like a ripple frozen in time, curving upward and downward in gentle arcs. This warp may have been caused by past gravitational encounters, collisions with smaller galaxies or interactions with massive halos of dark matter. Such distortions are common among spiral galaxies and offer clues to their dynamic histories. The bending of Andromeda's disk shows that galaxies are not static pinwheels but living systems, continually reshaped by the gravitational tides of their surroundings. The story of Andromeda, from its bright arms to its dark halo, is the story of the universe itself, one of creation, transformation, and renewal. Within its arms, new stars ignite from clouds of dust and gas. In its core, ancient suns burn quietly, marking the passage of cosmic ages. Around its edges, invisible forces sculpt the very shape of space. And far beyond, in the silent dark between galaxies, its influence stretches outward, touching the Milky Way as both are drawn toward their inevitable union. Someday, countless billions of years from now, the galaxy's separate lights will merge into one brilliant glow, and the distinction between Milky Way and Andromeda will fade into memory. The night sky will be transformed into a spectacle of endless starlight, and the story of our cosmic neighborhood will enter a new era. Even then, long after our Sun and Earth are gone, the light of Andromeda's stars, and the merged galaxy they will become, will continue to shine across the universe. Their photons will travel outward for millions of years, reaching worlds that do not yet exist, carrying with them the story of how two galaxies met and became one. It is a gentle reminder that nothing in the cosmos truly ends. Everything changes, evolves, and begins again. The merging of the Milky Way and Andromeda will not be an ending, but a continuation, another chapter in the endless unfolding of creation. And as you close your eyes tonight, imagine those spiraling rivers of stars, those ancient suns slowly drifting together across eons, weaving a new pattern in the sky. Let that vast, timeless motion fill your mind with calm. The universe moves slowly, steadily, beautifully, and in its eternal rhythm. Every moment, every star, every breath becomes part of something infinite. The warp of Andromeda's vast galactic disk is subtle but immense, lifting enormous swaths of stars and interstellar material thousands of light-years above and below the central plane, a silent ripple in the cosmic sea that hints at a turbulent and ancient past. These grand distortions often occur when a galaxy undergoes gravitational encounters with others, pulling and bending its once flat structure into graceful arcs and waves frozen in time. Beneath Andromeda's calm spiral arms lies the story of chaos and creation, a record of galactic collisions, gravitational tides, and the slow, majestic ballet of cosmic motion. Even across millions of light-years, astronomers can see these ripples imprinted in the very arrangement of its stars, a luminous memory of past interactions preserved in the structure of the galaxy itself. The evidence suggests that Andromeda's serenity is deceptive. Beneath its soft glow lies the restless energy of an evolving universe, where no galaxy, no matter how still it appears, is ever free from the pull of time and gravity. These warps likely arose from past galactic collisions, slow, vast interactions that transformed Andromeda's shape over billions of years. Unlike the fiery explosions imagined by human minds, galactic collisions are largely silent. The stars within rarely collide directly, for the space between them is immense. Instead, their collective gravities engage in a long, elegant dance that reshapes entire galaxies without a sound. Astronomers believe that Andromeda's warped disk and the faint streams of stars surrounding it are scars left behind by such cosmic events. Long ago, smaller galaxies may have strayed too close, torn apart by Andromeda's powerful gravitational field. Their fragments were drawn inward, their stars scattered like celestial dust into arcs and loops that ripple across the galactic plane. The once flat disk of Andromeda bent and twisted under the tension of these gravitational interactions, like the surface of a pond disturbed by falling stones. Over countless eons, these ripples froze into form, shaping the contours astronomers observe today. By tracing the geometry of the warp, scientists can piece together the hidden history of Andromeda's past, reconstructing the stories of galaxies that once existed but are now gone, absorbed into its greater whole, ancient civilizations of stars whose light has long since dimmed. Surrounding Andromeda is a vibrant family of smaller galaxies, its many companions, orbiting in patient, silent circuits. Like our own Milky Way, Andromeda is not alone in the dark. It is encircled by dozens of satellite galaxies, each one a faint smudge of light when viewed through a telescope, some bright and distinct, others ghostly and barely perceptible. These companions are often dwarf galaxies rich in old stars, some perhaps the faded remnants of once larger galaxies consumed by Andromeda's gravity. Their orbits tell a story of constant interaction, drawn ever closer by the gravitational pull of their enormous neighbor. Over millions of years, Andromeda gathers these smaller companions into its growing gravitational family, consuming them slowly in a process astronomers call galactic cannibalism. It is through this gradual merging that great galaxies grow, through the quiet assimilation of others, each encounter adding new stars, new elements, and new stories to their structure. The space around Andromeda is thus far from empty. It is alive with motion, filled with the silent dance of smaller galaxies circling, some fated to survive for billions of years, others destined to be torn apart. As Andromeda's gravity pulls on these smaller satellites, their stars begin to stretch and drift, forming long tidal streams that wrap around the galaxy in faint, glowing ribbons. Over time, these weaker galaxies lose their distinct shapes, their light scattering into great arcs that spiral inward like threads drawn into a vast loom. This slow, invisible consumption has no violence, no sound, only beauty and inevitability. Through it, Andromeda grows, incorporating the material of its neighbors into itself. Observations have revealed ethereal arcs and faint streaks of starlight surrounding Andromeda, the pale remnants of galaxies long ago devoured. Each thread of light in the dark sky is a memorial, the last trace of a vanished world whose stars were recycled into the luminous body of a greater being. Through this endless cycle of destruction and creation, the universe builds itself anew. Even now, deep within Andromeda's halo, new streams of stars are forming as tiny galaxies surrender to its immense gravitational pull, feeding the ever-turning wheel of cosmic evolution. Not all of Andromeda's stars were born under its own skies. Many began their lives in other galaxies, drifting through the void before being captured by Andromeda's embrace. These stars carry within them the fingerprints of their origins, the unique chemical compositions that reveal where they once belonged. Astronomers have learned to read these stellar signatures like ancient scripts written in light. Some of Andromeda's stars are poor in heavy elements, a clue that they were formed in smaller, older galaxies that merged with Andromeda long ago. Together, these diverse stars form a cosmic mosaic, a vast, galactic tapestry woven from countless mergers and migrations. Andromeda's beauty, therefore, is not the product of a single birth, but the cumulative result of many lives and many collisions across deep time. Each new arrival has added its own hue to the galaxy's glow, each merger enriching its complexity and grandeur. In the galaxy's outskirts, these stories linger most visibly. Long, faint trails of starlight, the stellar streams, stretch across hundreds of thousands of light years, tracing the exact paths of galaxies that once orbited before being torn apart. Astronomers study these streams not only for their haunting beauty but for the secrets they reveal. By mapping their paths and measuring their motion, scientists can reconstruct Andromeda's dynamic history, identifying when and how each collision occurred. These star streams are fossilized echoes of cosmic events, relics of creation through absorption. Their delicate curves also act as cosmic tracers, revealing the influence of something unseen, dark matter. As the streams wind through Andromeda's halo, their arcs bend in ways that betray the presence of invisible mass, allowing astronomers to chart the hidden landscape of gravity that shapes the galaxy. The deeper we look, the clearer it becomes that Andromeda is a creature of transformation. Its structure is not the product of serenity but of consumption and change. The warped disk, the faint debris fields, and the overlapping stellar populations all tell the same story. Andromeda has built itself through cosmic cannibalism. Its halo contains stars of many origins, its disk bears the scars of ancient mergers, its outer edges shimmer with the dust of galaxies that no longer exist. Every sign points to a long and intricate evolution shaped by gravitational hunger. Astronomers no longer view Andromeda as a single entity but as a layered monument, an accumulation of hundreds of billions of stars born in different places and times, all drawn together by the invisible hand of gravity. Even its elegant spiral arms, those luminous rivers of starlight, may owe their shape to these encounters, their geometry molded by the tidal forces of past collisions. Yet this form of destruction is also creation. It is the quiet metabolism of the cosmos. Galaxies consume others, not in malice, but as part of the universe's natural cycle of growth. Through the endless process of merging, stars are reborn, gas clouds are reignited, and new generations of suns begin to shine. Andromeda's grandeur, therefore, is not a static beauty but a beauty in motion, an ongoing story of rebirth, reconstruction, and renewal across cosmic ages. Yet perhaps the greatest mystery of Andromeda lies not in its visible stars, but in what cannot be seen at all. Only a small fraction of the galaxy's total mass comes from luminous matter, the glowing stars and clouds of gas we can detect. The rest, far more substantial, is made of something invisible, dark matter. This enigmatic substance neither emits nor absorbs light, yet its gravitational influence shapes the entire structure of Andromeda and every galaxy in the cosmos. Without dark matter, the outer stars of Andromeda would not orbit as they do. They would drift away into the void. Its presence is what holds the galaxy together, binding the luminous and the unseen into one gravitational whole. When astronomers measure the movement of Andromeda's stars, they find that the outermost ones travel far faster than the visible mass alone can explain. Something massive and unseen must be providing the extra gravity needed to maintain this speed, an invisible scaffold upon which the galaxy is built. By studying how quickly stars rotate at different distances from the center, scientists can map the distribution of dark matter throughout the galaxy. They find that this mysterious halo of unseen matter extends far beyond Andromeda's visible spiral arms, perhaps 10 times the mass of all its stars combined. It forms an immense, transparent cocoon surrounding the galaxy, a cosmic skeleton upon which its luminous structure is draped. This dark matter not only shapes Andromeda's destiny but connects it to the wider web of the universe, linking it invisibly to every other galaxy across vast stretches of space. Through all these revelations, Andromeda emerges not just as a distant spiral of light, but as a living chronicle of the universe's history, a record of collisions, births, deaths, and transformations that span billions of years. Its warps, streams, and unseen halo tell us that even in the stillness of the night sky, nothing is truly still. The galaxy is a reminder that beauty in the cosmos is born of motion and change, that what seems eternal is, in truth, a moment in an unending story of evolution. From the faintest dwarf galaxies drawn into its orbit to the invisible dark matter that binds it all together, Andromeda is a masterpiece of gravitational artistry, a silent symphony of forces shaping the fate of stars. And in its reflection, we see not just another world, but the destiny of our own Milky Way, for one day, in the far future, the two great spirals will merge, continuing the cycle of creation that defines the cosmos itself. The smooth, consistent motion of Andromeda's stars reveals a vast and invisible presence surrounding it, a massive halo of dark matter stretching far beyond the luminous spiral we can see. This hidden framework, inferred through the motion of billions of stars, gives astronomers one of the clearest windows into how dark matter shapes the grand architecture of galaxies across the universe. Within Andromeda's majestic arms lie immense clouds of glowing hydrogen gas, the raw material of new stars. When ultraviolet starlight energizes this gas, it glows in shades of pink and red, forming vast nebulae that stretch for thousands of light years. These delicate yet immense structures are the cradles of creation, regions where gravity draws dense clumps of gas together until nuclear fusion ignites within them, birthing new suns. The process is both violent and beautiful. Turbulent clouds of gas and dust swirl, collapse, and flare with the first light of newborn stars, each one marking a new chapter in Andromeda's long history. These stellar nurseries are sculpted by powerful stellar winds and radiation that carve cavities and filaments through the gas, shaping intricate, smoke-like patterns that shimmer in space. Many of these stars form in clusters, their collective light illuminating Andromeda's spiral arms with brilliant color. Some of the newly born stars are massive and short-lived, destined to explode as supernovae after only a few million years, while others, smaller and steadier, will shine for billions. Observing these regions allows astronomers to witness the same process that once gave birth to our own sun, a living demonstration of how creation continues in every corner of the cosmos. High above Andromeda's glittering disk, astronomers have detected colossal bubbles of hot gas, each tens of thousands of light-years wide. These vast, glowing forms are visible only in X-rays, silent witnesses to the tremendous energy released by waves of supernova explosions and fierce stellar winds. Like a cosmic exhale, these bubbles vent energy and matter into Andromeda's surrounding halo, helping the galaxy regulate its own growth by balancing creation with release. Though invisible in ordinary light, they mark Andromeda as a dynamic, breathing entity, an immense ecosystem where birth, death, and transformation intertwine over millions of years. The bubbles may have formed during periods of intense star formation known as starbursts, brief but dramatic episodes when new stars are born in extraordinary numbers. During these cosmic surges, massive stars form and die in rapid succession, releasing torrents of energy that push gas outward from the galactic core. Over millions of years, these eruptions create immense cavities that expand above and below the galaxy's plane, carrying enriched material back into the halo. This recycled gas, infused with heavy elements forged in stars, eventually cools and falls back into the galaxy, seeding future generations of stars and planets. In this way, Andromeda's violent outbursts feed its long-term evolution, showing that galaxies are not static structures but living systems that grow, breathe, and renew themselves through cycles of destruction and creation. Throughout Andromeda, supernova explosions continue to reshape the galaxy's interstellar medium. While most stars spend their lives quietly, shining for billions of years, some end in spectacular collapse, releasing more energy in a single instant than the Sun will produce in its entire lifetime. Thousands of such events have occurred across Andromeda over cosmic time, each one scattering heavy elements like iron, oxygen, and gold into space. These explosions not only enrich the galaxy but also compress nearby gas clouds, triggering new waves of star formation. The heavy atoms forged in these dying stars become the raw materials for future worlds, planets, moons, and perhaps even life itself. Through this unending cycle of death and rebirth, Andromeda continually renews its structure and light. Its luminous beauty, visible from over 2 million light-years away, is the product of countless generations of stars living, dying, and giving back their substance to the cosmos. Seen through a telescope, Andromeda's spiral arms blaze with the bright blue light of young stars, massive, hot, and short-lived. Their sapphire glow traces the galaxy's graceful spiral structure, revealing regions where creation is most active. These young suns form in dense clusters within vast hydrogen clouds, and the ultraviolet radiation they emit causes surrounding gas to glow, outlining Andromeda's arms in shimmering color. Though their lives are fleeting compared to cosmic time, these stars embody the galaxy's youthful vigor. Each blue light represents a brief but brilliant moment in an ancient story, a testament to the ceaseless creativity that drives galaxies forward. Closer to the center, however, the scene changes. There, the light softens into golden and reddish hues as older stars dominate. These ancient suns have long since burned through their prime fuel and now glow with quiet endurance, forming a dense and stable bulge of stars orbiting the galaxy's central black hole. This contrast between the radiant blue of the spiral arms and the warm amber of the core captures the passage of cosmic time, a visual record of how galaxies evolve from fiery youth to mature stability. Over billions of years, Andromeda's central regions have slowed their star formation, settling into a tranquil glow that speaks of age and endurance. Yet even within this apparent calm, Andromeda remains a galaxy in motion. Star formation across its disk is not uniform but patchy and rhythmic. Some regions blaze with the light of newborn clusters, while others rest in darkness, awaiting the next wave of creation. These patterns are shaped by the complex interplay of gas, dust, and magnetic fields that thread through the galactic disk. Where cold hydrogen is plentiful, gravity gathers it into dense clouds that collapse into stars. Elsewhere, where the gas is too hot or too diffuse, star formation pauses. The motion of the spiral arms themselves creates waves of density that sweep through the disk, compressing gas in periodic cycles and igniting new stars along narrow, curved bands. This pulsing rhythm gives Andromeda its characteristic pattern, a living, breathing tapestry of light and shadow. Far beyond the luminous spiral arms, Andromeda's vast halo extends into the darkness, composed of faint stars, ancient clusters, and invisible clouds of dark matter. This halo, stretching for hundreds of thousands of light years, is the silent foundation upon which the galaxy's visible form rests. It contains the remnants of smaller galaxies long ago absorbed by Andromeda, their stars now scattered like embers across the void. Within this vast domain, gravity reigns supreme, binding together stars, gas, and dark matter into one cohesive structure. The halo's presence is betrayed not by light but by motion, the subtle dance of stars orbiting far from the galactic center, their paths bending under the influence of unseen mass. Through such observations, astronomers have come to understand that dark matter outweighs the visible components of Andromeda by a vast margin, shaping not only its rotation but also its evolution over cosmic time. Andromeda is not static, it is a galaxy in transition. Even now, it drifts slowly toward our own Milky Way, drawn by the mutual pull of gravity. In roughly 4 billion years, the two galaxies will merge, forming a single, massive elliptical galaxy. The stars themselves will rarely collide, but their gravitational interactions will transform both systems, scattering stellar orbits and igniting new waves of star formation as gas clouds compress in the chaos. The resulting galaxy, sometimes called Milkomeda, will carry the combined legacy of both, their stars intermingled, their histories woven together. For now, however, Andromeda remains a distant beacon in the northern sky, the largest and brightest galaxy visible to the naked eye. Its light, traveling for more than 2 million years before reaching Earth, shows us the galaxy as it once was, an ancient snapshot of creation in progress. Through telescopes, we glimpse Andromeda's vast spiral arms, its golden core, and the faint halo that envelopes it, all bathed in the quiet majesty of cosmic time. Each photon that reaches us is a messenger from the past, carrying the story of stars being born, living, and dying long before humanity existed. The beauty of Andromeda lies not only in its luminous form but in what it represents, the continuous cycle of creation and transformation that defines the universe itself. Its glowing hydrogen clouds remind us that even in the silent void of space, new light is always being born. Its supernova remnants remind us that endings are also beginnings. Andromeda's story is the story of the cosmos, a tale of balance between chaos and order, of light rising from darkness, of energy flowing endlessly through time. From the youngest blue stars in its spiral arms to the oldest red suns in its heart, from the faint whispers of dark matter shaping its motion to the radiant nebulae glowing with new life, every part of the galaxy participates in a grand symphony of motion and change. To gaze upon Andromeda is to look into a mirror of our own galaxy's fate, to witness the rhythm of creation that pervades all things. Though its inner regions have slowed with age and its outskirts continue to shine, the galaxy remains alive, a timeless engine of birth, death, and renewal, turning silently in the vast sea of stars. In the central regions of the Andromeda Galaxy, the raw material for star formation has been largely consumed over billions of years, as vast reservoirs of gas were either transformed into stars or driven outward by the force of ancient stellar winds and supernova explosions. What remains in these inner zones now glows with the soft, steady light of older, longer-lived stars that have settled into calm orbits around the galactic core, their subdued radiance marking the mature heart of a once fiercely active region. In contrast, the galaxy's far-flung outer arms remain rich in cold hydrogen gas, the essential ingredient for the next generations of stars yet to be born. This uneven distribution of gas creates a kind of temporal layering across Andromeda, where its ancient, golden center coexists with a youthful and energetic rim, offering astronomers a living timeline of galactic evolution. By studying these contrasts, scientists trace how galaxies age, how they transform from fiery star-forming cauldrons into graceful, luminous systems of long-lived suns. The bright, active edges of Andromeda serve as a reminder that even in old age, a galaxy continues to create, maintaining quiet pockets of vitality along its sprawling spiral arms where the cosmic cycle of birth and renewal persists in patient rhythm. Threaded through these glowing arms are swirling ribbons of interstellar dust, dark lanes that twist and coil like smoke against the shining backdrop of starlight. Through powerful telescopes, these lanes appear as shadowy streaks crossing Andromeda's luminous face, but they are anything but empty. Composed of microscopic grains of carbon and silicate, remnants of stars that lived and died long ago, this dust absorbs and scatters light, sculpting the galaxy's appearance while harboring the cool, dense regions where new stars will eventually form. Far from being voids, these dust lanes are fertile ground, the very soil of cosmic creation. Their intricate structures trace the flow of gas and dust under the influence of Andromeda's gravity, revealing the hidden choreography of matter spiraling inward along the arms. When viewed through infrared telescopes, what once appeared dark now glows faintly with warmth. The dust, gently heated by the starlight around it, radiates soft energy at longer wavelengths, unveiling a glowing network invisible to the naked eye. Instruments like the Spitzer Space Telescope and the James Webb Space Telescope have peered into these veiled regions, uncovering infant stars still cocooned within their birth clouds. The result is a transformed image of Andromeda's hidden architecture, a delicate tapestry of light and shadow, heat and silence. It is a vivid reminder that even the coldest regions of space are alive with energy, that every shadow hides a pulse of light, and that every quiet corner of the universe hums with unseen creation. Andromeda radiates across every part of the electromagnetic spectrum, each wavelength revealing a different layer of its character. In ultraviolet light, its spiral arms blaze with bright, energetic patches marking the locations of massive, young stars, clusters of hot, newborn suns emitting fierce ultraviolet radiation that shapes and heats the surrounding gas. These glowing knots of activity are cosmic nurseries, each less than a few million years old, where gravity and energy wage their eternal battle to build new light. By mapping this ultraviolet glow, astronomers can chart Andromeda's current rate of star formation and identify the most vibrant regions of its disk. Seen in ultraviolet, The galaxy appears almost skeletal, its framework outlined by luminous threads of creation, an intricate, living blueprint of its youngest stars. The ultraviolet portrait of Andromeda captures the galaxy in motion, revealing its restless, creative energy still at work after billions of years. Before these stars ignite, however, their raw material exists as immense clouds of cold hydrogen gas, vast, invisible reservoirs stretching across and beyond the visible spiral. These regions emit faint radio signals at a precise wavelength of 21 centimeters, a signature of neutral hydrogen that astronomers detect using giant radio telescopes. By tuning into this frequency, scientists can map Andromeda's hidden structure, tracing enormous spiral arms of gas extending far into space, beyond what optical telescopes can see. This cold hydrogen is the galaxy's storehouse of future starlight, destined to collapse under its own gravity to form the next generation of stars and planets. In radio maps, Andromeda's true scale is revealed, its faint outer arms curling through the darkness like whispers of what is yet to come. Each cloud of gas represents potential, a quiet promise of stars waiting to be born. Thus, the radio image of Andromeda is not just a picture of what it is, but a preview of what it will become, a forecast of future brilliance written in invisible waves. When viewed across the entire electromagnetic spectrum, from radio to infrared, visible, ultraviolet, and X-ray light, Andromeda emerges as a complete and dynamic system. Each wavelength tells a different part of its story. Radio waves trace the cool gas that fuels star formation. Infrared light reveals the gentle warmth of dust and hidden stars. Visible light shows the sweeping spiral arms in full glory. Ultraviolet highlights the hot, young clusters blazing with new life, and X-rays expose the violent remnants of exploded stars and the energetic heart near the central black hole. Together, these layers form a multidimensional portrait of a galaxy alive with complexity. No single view can reveal its full truth. Only by weaving together all these wavelengths can astronomers glimpse Andromeda's total nature, from the quiet outer rim to the turbulent, radiant core. In this cosmic symphony of light, we see the full spectrum of existence, from the cool calm of potential to the fierce heat of creation, from death's explosions to rebirth's glow, all bound within one vast celestial masterpiece. Because of its proximity and grandeur, Andromeda has become one of the most studied galaxies in the universe. Orbiting observatories have devoted countless hours to its observation. The Hubble Space Telescope has produced breathtaking mosaics of its spiral arms, capturing billions of stars in exquisite detail. The Chandra X-ray Observatory has examined the energetic aftermath of stellar explosions in its core, while the James Webb Space Telescope has probed its dusty outskirts, revealing new structures once hidden from view. Together, these instruments have transformed Andromeda into a cosmic laboratory, an invaluable testbed for understanding how galaxies like our own Milky Way evolve. Because it is both near and structurally similar to our galaxy, Andromeda serves as a mirror in which we can study processes otherwise invisible in distant systems. Every image, every wavelength, every discovery deepens humanity's understanding of how galaxies live, age, and interact. It is not merely a distant smudge in the night sky, but a cornerstone of modern astronomy, a benchmark against which we measure our knowledge of the universe and our place within it. Yet, this understanding is relatively recent. For centuries, the true nature of Andromeda was a mystery that sparked one of the greatest debates in the history of science. To early astronomers peering through modest telescopes, Andromeda appeared only as a faint, hazy patch, a nebulous glow in the constellation that shared its name. It was often called the Great Andromeda Nebula, and its distance was unknown. Some scientists believed it was merely a cloud of gas within our own Milky Way, perhaps a nearby cluster of stars shrouded in mist. Others speculated that it could be something far grander, an island universe, beyond our own galaxy. The debate raged through the 19th and early 20th centuries, fueled by the limits of observation and the boundless curiosity of the human mind. Was Andromeda part of our cosmic neighborhood, or an entirely separate realm across an unimaginable gulf of space? Without precise ways to measure distance, the truth remained elusive. For generations, it hovered at the edge of comprehension, visible to the eye, yet incomprehensible in scale. This uncertainty reflected a deeper yearning in humanity's relationship with the cosmos, a desire to know whether our galaxy was unique or one among countless others. Andromeda became a symbol of that mystery, a ghostly light in the sky representing both the known and the unknown. Then, in the early 20th century, a breakthrough came with the advent of long-exposure astrophotography. As astronomers began to capture the faint light of distant objects over many hours, Andromeda's true nature started to reveal itself. Among the most famous of these efforts was the work of Edwin Hubble, who, using the 100-inch Hooker telescope at Mount Wilson Observatory, identified individual Cepheid variable stars within Andromeda. By measuring their brightness and applying the known relationship between their luminosity and distance, he made a revolutionary discovery. Andromeda lay far beyond the boundaries of the Milky Way. It was not a nearby nebula but a separate galaxy, an entire universe of its own, millions of light-years away. This single observation forever changed our understanding of the cosmos. The universe expanded in an instant, not in size, but in our perception of it. What had once been thought of as the entire cosmos, our Milky Way, was revealed to be just one of countless galaxies spread across the boundless fabric of space. Andromeda became the first doorway to that vastness, the first proof that we were not alone in the universe of galaxies. Its faint glow, once dismissed as a wisp of light, became a symbol of discovery and perspective, a reminder of how knowledge can transform mystery into meaning. Today, when we gaze at Andromeda through telescopes or even with the naked eye from a dark mountain night, we are witnessing not just a distant galaxy, but the light of billions of stars that began its journey more than 2 million years ago. We see it as it once was, its past still traveling through the vacuum of space to reach our eyes. Within that light lies the story of time itself, a chronicle of creation, decay, and renewal on scales that dwarf our imagination. Every wavelength, every glow of dust, every flicker of ultraviolet energy tells a part of that timeless narrative. Andromeda stands as both an object of study and a source of wonder, a mirror reflecting the story of our own galaxy's evolution and a reminder of the unbroken continuity of cosmic life. To look upon Andromeda is to glimpse eternity, a galaxy that bridges past and future, old stars and new, death and rebirth. From its silent dust lanes and glowing hydrogen clouds to the invisible halos of dark matter that hold it together, it embodies the full spectrum of the universe's creativity. Its heart beats with the memory of stars long gone. Its edges shimmer with the promise of stars yet to be born. It is a masterpiece of motion and time, a living testament to the endless, self-renewing beauty of the cosmos. In the early 20th century, a single photograph forever changed humanity's understanding of the universe. Taken by the astronomer Edwin Hubble using the Hooker telescope at Mount Wilson Observatory, this image revealed something extraordinary within what was then known as the Andromeda Nebula. Among its luminous spirals, Hubble identified faint, pulsing points of light known as Cepheid variable stars, celestial beacons whose rhythmic fluctuations in brightness could be used to determine their true luminosity and distance. When Hubble analyzed their light, he discovered something astonishing. These stars were far beyond the boundaries of the Milky Way. This meant that the Andromeda Nebula was not a nearby cloud of gas and dust within our galaxy, as previously believed, but a vast, independent galaxy millions of light-years away. The revelation was staggering. With one photograph, Hubble transformed the Andromeda Nebula from a local curiosity into an entirely separate galaxy, a colossal island of stars existing far outside our own. This moment marked a turning point in human history, the birth of modern extragalactic astronomy, and it expanded our known universe beyond comprehension. Until that discovery, astronomers believed that the Milky Way contained everything in existence, that all stars and nebulae resided within a single galactic system. The realization that Andromeda was another galaxy redefined the scale of creation. The universe, once thought to be a single shining city of stars, became an infinite archipelago, with galaxies as its countless islands scattered across the vast cosmic ocean. Hubble's measurements, based on the light of Cepheid variables, placed Andromeda more than 2 million light-years away, an almost unimaginable distance at the time. His calculations shattered the idea of a small, self-contained cosmos and revealed instead a universe teeming with galaxies of every shape and size, stretching endlessly in all directions. This discovery not only expanded the known cosmos but also transformed humanity's place within it. The Milky Way was no longer the center of creation, nor even a significant structure in a boundless universe. We were, for the first time, aware that our galaxy was one among billions, a modest spiral adrift in an infinite sea of starlight. The impact of this revelation was both scientific and philosophical. It changed our sense of scale, time, and purpose. Suddenly, human existence appeared more fragile, yet also more profound, as we realized we were part of a cosmic story far greater than ourselves. Hubble's discovery also paved the way for another monumental breakthrough, the realization that the universe itself is expanding. As Hubble continued his observations of other distant galaxies, he noticed that their light was stretched toward the red end of the spectrum, a phenomenon known as redshift. This shift indicated that these galaxies were moving away from us, implying that the fabric of space itself was expanding. From this observation arose one of the most powerful concepts in science: that the universe had a beginning, that it is growing larger with time, and that galaxies are not static points but dynamic participants in an ongoing cosmic evolution. Andromeda, however, stood out as a rare exception. It was moving toward us rather than away. Its approach became a symbol of cosmic interaction, suggesting that galaxies could also merge and transform one another over eons. In fact, scientists now know that billions of years from now, Andromeda and the Milky Way will collide, blending into a single, larger galaxy often dubbed Milkomeda. Thus, Andromeda serves both as a clue to the universe's expansion and as a glimpse into its future, a reminder that creation is a living process of constant motion and renewal. The Cepheid variable stars that Hubble observed in Andromeda remain among the most important tools in astronomy. These stars pulsate with precise regularity. Their brightness rises and falls in a repeating cycle determined by their intrinsic luminosity. By comparing how bright they appear from Earth to how bright they truly are, astronomers can calculate their distance with remarkable accuracy. This method became known as the cosmic distance ladder, the foundation upon which the scale of the universe was built. The first rung of that ladder was Andromeda, and every subsequent measurement of distant galaxies and clusters ultimately traces back to the light of those Cepheid variables flickering millions of light years away. Their steady rhythm turned starlight into a ruler of the cosmos, transforming light itself into a language of geometry and time. Each pulse of brightness carried a message across intergalactic space, whispering the distances between worlds and revealing the vastness of the universe one beat at a time. When Hubble first recorded those faint signals, the implications were beyond imagination. The light from those stars had been traveling toward Earth for millions of years, long before humanity ever existed, crossing the silent darkness between galaxies to deliver its ancient message. By decoding that light, Hubble and his peers were, in a sense, communicating with the distant past, uncovering truths that had lain hidden since the dawn of time. The realization that the universe extended far beyond our own galaxy was both humbling and exhilarating. Humanity's sense of place in the cosmos was rewritten overnight. No longer were we inhabitants of a singular cosmic island. We were citizens of an infinite universe, surrounded by countless other galaxies, each containing billions of stars, perhaps each with their own planets, and perhaps their own forms of life. The discovery also inspired generations of astronomers, physicists, and dreamers to look outward. Every time Andromeda rises in the night sky, a faint, misty oval visible even to the naked eye, it stands as a symbol of human curiosity and discovery. It reminds us of that transformative moment when the boundaries of the known world dissolved, and the universe opened wide before us, inviting us to explore without end. Andromeda became more than an astronomical object. It became a mirror of our own journey toward understanding. It showed that what once appeared small and familiar could, with deeper vision, reveal an infinity beyond comprehension. Through Andromeda, Hubble not only expanded the universe but also deepened the mystery of our own existence. He taught us that every flicker of light in the night sky may hold within it a story older than time itself, waiting patiently for the moment when human curiosity grows sharp enough to see it clearly. The Cepheid variables that guided Hubble's discovery still pulse today, their light crossing millions of light-years of emptiness, a heartbeat of the cosmos reaching our telescopes from across space and time. They remain silent messengers of distance and scale, their rhythms a cosmic clock that continues to tick, connecting us to the farthest reaches of the universe. Through them, we measure not only the structure of galaxies but also the progress of our own understanding. In their faint, ancient glow lies the record of how far we have come, from the first observers who mistook Andromeda for a cloud of gas, to the modern astronomers who now peer deep into its spiral arms with space telescopes, studying stars, dust, and planets within it in exquisite detail. The light that revealed Andromeda's true nature continues to guide us toward ever greater horizons. Each discovery since Hubble's time has built upon that moment, when humanity first realized that we were not alone in the cosmos. His photograph was more than a scientific achievement. It was a revelation of perspective, a door opening to infinity. The universe suddenly became much larger, and so did the human spirit. What was once thought to be the entirety of creation turned out to be a single speck within a boundless expanse. The Milky Way, once the whole of existence, was now just one galaxy among billions. The scale of reality expanded from thousands to billions of light years, and with it expanded our imagination, our sense of wonder, and our understanding of what it means to exist. The Andromeda Galaxy, once a faint blur in a telescope, became the first great signpost pointing toward the vast, living universe beyond. And because of Hubble's vision, we now know that every patch of darkness in the sky hides countless galaxies like Andromeda, each one a city of stars, each one a potential home for new worlds, new mysteries, and perhaps, new life. Thus, Andromeda's faint light, crossing millions of years to reach us, did more than illuminate the night, it illuminated our minds. It proved that the universe is far greater, far older, and far more beautiful than anyone had ever imagined, and that our desire to understand it is as endless as the stars themselves. The Andromeda revelation became a moment of awakening, much like the first time humanity realized that Earth revolves around the Sun. It expanded our understanding of the cosmos, revealing that the universe was not a single, isolated structure but an infinite landscape filled with countless galaxies, each a potential home to unnumbered stars and worlds beyond imagination. Among these galaxies, Andromeda stands as our nearest spiral neighbor, moving toward us at a speed exceeding 200 kilometers per second. Unlike most galaxies, which drift away as the universe expands, Andromeda is on an inbound path toward the Milky Way. This motion is revealed through the slight shift of its light toward the blue end of the spectrum, a phenomenon known as blue shift, signifying that it is approaching. Though the speed seems astonishing, the distance separating our galaxies is so vast that their eventual meeting lies billions of years in the future. The mutual pull of gravity between these two colossal systems draws them closer, their attraction a slow yet inevitable process in the grand choreography of cosmic evolution. Already, their massive halos of gas and dark matter begin to intermingle, forming subtle bridges of material that foreshadow their eventual union. This gravitational connection is not an act of violence but of cosmic destiny, a gentle and ancient tide that will ultimately weave the Milky Way and Andromeda together into a single, magnificent structure. Over the span of roughly 4 billion years, their gradual approach will culminate in an immense cosmic dance. When they finally begin to merge, the gravitational forces at play will stretch their spiral arms into vast arcs of light, blending their stars into swirling new patterns. Though the word collision might suggest destruction, it will instead be a graceful transformation, a process that has shaped galaxies across the universe since its earliest epochs. The meeting of Andromeda and the Milky Way will mark not an end, but a renewal, a reorganization of stars, dust, and gas into a larger, more luminous entity. Despite each galaxy containing hundreds of billions of stars, the spaces between them are so immense that direct collisions between individual stars will be exceedingly rare, almost impossible. Instead, the true effects will be gravitational. As the two galaxies interweave, the orbits of their stars will warp and bend under the combined gravitational field, creating elegant loops and arcs that may span thousands of light years. Some stars will be cast outward into tidal tails, glowing ribbons stretching far beyond the visible core, while others will drift inward, forming dense new clusters at the heart of the merged system. The clouds of interstellar gas, however, will collide and compress, sparking bursts of new star formation that will fill the night with fresh brilliance. This event will not destroy but rather rekindle stellar life, as shockwaves ignite vast regions of new light. From afar, the merging galaxies will appear as two luminous spirals entwined in a slow, radiant embrace, gradually fusing into a single gleaming orb amid the deep cosmic darkness. Gravity will sculpt a new celestial form, guiding billions of stars into new orbits. Over immense spans of time, the symmetrical spiral arms of each galaxy will dissolve, giving way to a more elongated, oval structure. Simulations suggest that after this long and chaotic interaction, the combined system will eventually relax into a state of equilibrium, forming a serene and stable galaxy once more. Within this future realm, stars will follow intricate paths, tracing the memory of two galaxies that became one. For any civilization that might still exist on Earth billions of years from now, the transformation of the night sky will be nothing short of breathtaking. As Andromeda draws nearer, it will appear larger and brighter, transforming from a faint smudge of light into a vast, luminous disk stretching across the heavens. Its spiral arms will gradually become visible to the naked eye, their glowing patterns painting the sky with threads of fire and mist. During the stages of merging, the heavens will be dominated by luminous rivers of stars, arcs of brilliance stretching across space. The process will unfold slowly, over millions of generations, yet its grandeur will be eternal. The constellations familiar to our present night will shift and fade, replaced by new arrangements of light shaped by the evolving cosmic dance. Humanity's descendants will witness the ultimate expression of galactic evolution, the merging of two majestic spirals into one vast elliptical form. As their interaction deepens, the immense gravitational forces between the Milky Way and Andromeda will distort their shapes, pulling stars and gas into sweeping tidal streams. These glowing trails, reminiscent of cosmic tides, will stretch across the void, each containing billions of stars spread thin over unimaginable distances. Some of these tidal streams will fall back toward the merging galaxies, drawn inward by gravity, while others will drift forever into intergalactic space, delicate ribbons of starlight fading into the abyss. Astronomers have observed similar structures around other galaxies, allowing us to glimpse our own future. These radiant bridges of light will endure for eons, silent monuments to the gravitational bond that once united two separate spirals into a single, harmonious whole. Eventually, after a long sequence of encounters and transformations, the Milky Way and Andromeda will settle into a stable, rounded form, a giant elliptical galaxy that astronomers have already given a poetic name: Milkdromeda, a union of both origins. The distinct spiral arms of each galaxy will fade away, replaced by a smooth, luminous spheroid filled with countless stars. The immense black holes at the centers of both galaxies will spiral toward each other, merging at last in a cataclysmic event that will release gravitational waves rippling across the fabric of spacetime. Though this dramatic finale will take billions of years to complete, its outcome will be serene, a vast, glowing structure shining quietly in the eternal darkness. Within this new cosmic city of stars, the legacy of both galaxies will live on, their histories entwined forever. The merging process itself will not be a single event, but a prolonged cosmic evolution. When the galaxies first encounter each other, they will pass through one another like ghosts, their stars scarcely interacting directly. Gravity will slow their retreat, pulling them back together for repeated encounters, each one reshaping their structures more profoundly. Over billions of years, loops of stars will stretch outward and collapse inward, while vast clouds of gas compress into new generations of suns. This cycle of approach, collision, and settling will continue until the chaotic motions of billions of stars gradually harmonize into a unified rhythm. The timescale of this transformation defies ordinary imagination, so long that entire lineages of stars will live and die during it. When the final calm emerges, the sky of that distant future will be utterly changed. From any surviving planet orbiting within this merged galaxy, the heavens will blaze with an overwhelming tapestry of light. The night will no longer hold the familiar constellations of our era, but a sprawling sea of radiance marking the unity of two once separate worlds. Andromeda and the Milky Way will have become one, an elegant symbol of the universe's endless cycle of creation, transformation, and renewal. What began as a faint blue shift in a distant glow will have culminated in one of the most magnificent events in the history of the cosmos: the birth of a new galaxy from the graceful union of two ancient spirals, forever entwined in the quiet majesty of the universe. In the vast rhythm of the universe, even events as grand as the merging of galaxies are natural and inevitable. Time itself acts as the sculptor of the cosmos, patiently shaping the destinies of stars and galaxies, weaving two ancient spirals into one eternal monument of starlight and silence stretched across the cosmic deep. When the Milky Way and Andromeda finally merge billions of years from now, our solar system will likely remain unharmed. Despite the immense gravitational forces that will reshape the galaxies, the space between individual stars is so unimaginably vast that the Sun and its family of planets will almost certainly pass through this event untouched. The solar system may drift to a new location within the merged galaxy, perhaps farther from the galactic center or among unfamiliar constellations, but it will survive the encounter intact. Over time, the view of the night sky will change completely. New clusters of stars will appear, and the bright, familiar band of the Milky Way may fade away as its spiral structure transforms into a more uniform glow. Yet, the sun will continue to shine, Earth will keep orbiting, and the heavens will remain alive with light. From our small corner of the cosmos, the event that seems so monumental on a galactic scale will unfold almost gently, a transformation that happens over billions of years, so slowly that life on Earth may scarcely notice. Far across space, in the Andromeda Galaxy itself, alien civilizations, if they exist, might already know of our presence. Perhaps, long ago, intelligent beings on some distant world in Andromeda turned their telescopes toward our Milky Way, studying the faint spiral glow that marks our home. From their perspective, they would see our galaxy as it appeared over 2 million years ago, because that is how long it takes light from the Milky Way to reach them. If their technology were advanced enough, they might even detect the spectral fingerprint of life, oxygen, methane, or other gases, in Earth's atmosphere, much as we now search for biosignatures on distant exoplanets. Yet, to them, humanity would not even exist. They would see an ancient version of Earth, a planet still in its prehistoric past, covered in forests and teeming with early life forms. Similarly, when we observe Andromeda through our telescopes, we are not seeing its present state but its distant history. The light that reaches our eyes left that galaxy millions of years ago, carrying with it an image of a long-vanished moment in time. In this way, the two galaxies are already linked, not through physical contact, but through the timeless exchange of light. Each serves as a mirror into the other's ancient past. If astronomers within Andromeda were to gaze toward us, they would see a version of the Milky Way frozen in time, its spiral arms subtly different, its stars younger, its shape perhaps less defined. They would see a sun that had not yet reached middle age and a world that had not yet birthed humankind. The finite speed of light ensures that every observation is also a journey backward through time. Thus, the vast expanse between galaxies is not just a gulf of distance, but a gulf of history, a living archive of the past written in light. When we look up at Andromeda's soft glow in the night sky, we are not peering across empty space but through the fabric of time itself, witnessing starlight that began its journey long before human civilization existed. The concept of communication between our galaxies stretches the imagination further. If an intelligent civilization in Andromeda attempted to send a message to us, that signal, even traveling at the speed of light, would take over 2 million years to arrive. A reply would require just as long to return, meaning any exchange of words or ideas would take more than 4 million years to complete. By the time the second message was received, both civilizations might have changed beyond recognition, or perhaps even ceased to exist altogether. Such impossibly vast timescales highlight the deep isolation of each world in the cosmos. Every radio wave, every photon of light that travels through the void becomes a kind of time capsule, a whisper from one age to another, drifting silently through eternity in the hope of one day being heard. And across that silence, the universe remains patient, ever listening. The possibility that life exists in Andromeda adds another layer of wonder. Within its hundreds of billions of stars, countless planets may orbit within the temperate zones where liquid water can exist, a key ingredient for life as we know it. Although we cannot yet see these planets directly, mathematical models and observations of our own galaxy suggest that millions of Earth-like worlds likely populate Andromeda's spiral arms, each orbiting a stable, sun-like star. Some might have atmospheres rich in oxygen, nitrogen, and carbon dioxide, while others could harbor oceans beneath layers of cloud or ice. There may be entire ecosystems thriving beneath alien suns, with landscapes shaped by forces both familiar and strange. Not all of Andromeda's stars are like our Sun, however. The galaxy contains a breathtaking diversity of stellar types. There are enormous blue giants, so hot and luminous that they burn through their fuel in mere millions of years, casting fierce ultraviolet light across space. There are cool, dim red dwarfs that glow faintly but persist for trillions of years, providing gentle, steady warmth to any planets that orbit them. Planets around blue giants would endure intense radiation, their skies flooded with searing light, while those around red dwarfs might exist in perpetual twilight, with one hemisphere forever facing the star and the other shrouded in darkness. Some stars exist in binary or even trinary systems, where planets orbit two or more suns, producing surreal skies with double shadows and shifting patterns of light. The sheer variety of stellar environments ensures an equally vast range of possible worlds, each one with its own chemistry, atmosphere, and rhythm of light and dark. Among Andromeda's many wonders are its rogue planets, lonely wanderers that drift through the galaxy without a parent star. Ejected from their home systems during gravitational encounters, these planets travel silently through the interstellar dark. Their skies are forever black, yet deep within their frozen interiors, some may retain warmth from radioactive decay or trapped heat from their formation. Beneath their icy crusts, hidden oceans may exist, providing refuge for simple forms of life. Astronomers estimate that there could be more rogue planets than stars in a typical galaxy, meaning Andromeda may harbor trillions of these unseen travelers. Each one is a solitary world adrift in endless night, a reminder that even in isolation, the universe holds infinite possibilities. The stars of Andromeda themselves form a vast and intricate mosaic. Within its sprawling expanse lie nearly every kind of star known to science: brilliant blue supergiants, aging red giants, compact white dwarfs, and ultra-dense neutron stars spinning at incredible speeds. There are also immense populations of ordinary sun-like stars, as well as countless faint red dwarfs that make up most of the galaxy's mass. This diversity offers astronomers a living laboratory for studying every stage of stellar evolution, from the birth of stars within glowing nebulae to their quiet deaths as white dwarfs or violent finales as supernovae. The colors of the galaxy reflect these life cycles. Young, energetic regions glow blue with hot new stars, while older, more mature areas shine red with the light of aging suns. Together, they form a living spectrum, a cosmic symphony of color and light representing nearly every possible phase of stellar existence. Surrounding Andromeda's luminous disk are hundreds of ancient globular clusters, dense, spherical gatherings of stars that have orbited the galaxy for billions of years. These clusters are among the oldest structures in the universe, relics from a time when galaxies were just beginning to form. Each contains hundreds of thousands of stars bound tightly together by gravity, shining like jeweled lanterns around the galaxy's halo. Within them may lie the oldest suns still burning, their light a direct link to the dawn of the cosmos. These globular clusters not only add beauty to Andromeda's profile but also preserve a record of its formation and evolution. They are the silent witnesses of cosmic history, drifting serenely in their orbits as the galaxy evolves and changes around them. In every way, Andromeda reflects the vastness and mystery of the universe itself. It is a microcosm of cosmic creation, filled with the birth, life, and death of stars, the dance of planets and moons, and the endless unfolding of time. Its future merger with our Milky Way is not an act of destruction but one of transformation, a slow and elegant blending that will reshape both galaxies into something greater than the sum of their parts. Through it all, the stars will continue to burn, planets will continue to turn, and light will continue to travel across the cosmic sea, carrying with it the eternal story of change, creation, and connection. The universe, in its infinite rhythm, continues to sculpt, recycle, and renew, and within that rhythm, even the most unimaginable events are but moments in the endless heartbeat of time. Each globular cluster in the Andromeda Galaxy contains hundreds of thousands of suns packed tightly into a space only a few dozen light-years wide, forming dazzling spheres of ancient starlight that illuminate the edges of the galaxy's vast halo. These stars are among the oldest ever known, born when the universe itself was still in its youth, their soft, golden glow a living relic of cosmic dawn. Their steady, graceful motions reveal the deep and patient rhythm of gravitational harmony that has endured for billions of years. To study them is to peer back through time, to the age when galaxies first assembled from clouds of primordial gas and dark matter. They form a kind of luminous crown around Andromeda, glowing faintly at its periphery, each cluster an ancient guardian that has orbited the galaxy for eons, preserving within its core the memory of an era when the first stars began to burn. Some of these clusters, such as the remarkable Mol-2 or G1, are colossal beyond imagination. G1 alone contains several million stars, its immense mass binding it together more tightly than most small galaxies. It shines as a faint but visible point of light just beyond Andromeda's edge, a ghostly ember of a dwarf galaxy that was long ago devoured and stripped to its core. These dense clusters serve as cosmic fossils, holding clues to the galactic collisions and mergers that shaped Andromeda into the spiral giant we see today. Yet even among these ancient assemblies, mysteries persist. Some clusters spin too quickly or move in ways that defy the predictions of gravity alone, hinting at the subtle pull of dark matter or the lingering scars of ancient interactions. Others are slightly elongated, their symmetry disturbed as if by unseen forces or passing shockwaves from nearby collisions. The slow motion of their stars tells silent stories of creation, of destruction, and of survival across cosmic time. They are living archives, their positions and velocities encoded with the secrets of Andromeda's evolution, allowing scientists to reconstruct the galaxy's hidden past. Beyond these clusters, Andromeda itself is threaded by an invisible yet powerful magnetic field that stretches for thousands of light years, tracing delicate lines of force through its spiral arms and outer halo. Though unseen by human eyes, this vast magnetic web is revealed through radio observations, which show elegant patterns following the rotation of gas and stars. The field acts as a galactic dynamo, generated by the motion of ionized gas combined with the spinning of Andromeda's massive disk. It influences the movement of charged particles, channels cosmic rays, and may even guide the formation of stars by shaping interstellar clouds. This unseen structure, delicate yet immense, connects every corner of the galaxy in a dynamic balance of energy and motion, demonstrating that even invisible forces play crucial roles in the evolution of cosmic systems. Within its grasp move the high-energy travelers known as cosmic rays, subatomic particles that stream endlessly through the universe, spiraling along magnetic lines like dancers in a silent current. As they move through Andromeda, these rays collide with gas and dust, producing faint radio and gamma-ray emissions that can be detected across unimaginable distances. Through these emissions, astronomers map the strength and geometry of the magnetic field, revealing how energy flows across the galaxy's interstellar medium. It is a subtle yet vital circulation, a quiet exchange between invisible forces that governs the heartbeat of the galaxy itself. Even more mysterious are the faint gamma-ray signals detected from Andromeda's halo. Observations from space-based telescopes reveal that the galaxy emits small but distinct amounts of gamma radiation, the most energetic form of light. Strangely, these emissions come not from stars or known sources but from seemingly empty regions. Scientists suspect they may arise from the interactions of dark matter particles, those invisible components that make up most of the universe's mass but remain unseen and unproven. If true, these signals could represent the first whispers of dark matter revealing itself through annihilation or decay, releasing bursts of high-energy photons as the invisible substance transforms into light. Others propose that the gamma rays are produced by cosmic rays accelerating within Andromeda's magnetic field, a process of immense energy and complexity. Regardless of the origin, these emissions remind us that even galaxies appearing calm and serene from afar conceal furious and mysterious activity deep within. Every photon that reaches us from these distant depths carries a message about the fundamental nature of reality itself. The possibility that dark matter may be illuminating the edges of Andromeda transforms the galaxy into a cosmic laboratory, a place where the universe's greatest mysteries might one day be solved. If confirmed, such findings would not only prove the existence of dark matter but also reveal its properties, offering insight into the unseen structure that binds galaxies together. Yet Andromeda's light does not shine only in the visible spectrum. When viewed in X-rays, an entirely different image emerges, one of violence, transformation, and rebirth. Scattered throughout its disk and halo are countless points of searing radiation, each a monument to the death or transformation of a star. Neutron stars, white dwarfs, and black holes mark the graves of long-dead suns, consuming gas from their surroundings and heating it until it blazes in X-rays. Between these compact remnants float clouds of hot gas millions of degrees in temperature, glowing softly in the invisible spectrum. These X-ray regions reveal the hidden processes that drive the galaxy's life cycle, how energy from dying stars spreads through the interstellar medium, compressing gas clouds and igniting new generations of suns. Among these X-ray beacons, a few stand out as extraordinarily bright, black hole binaries, where a stellar companion orbits too close to a black hole, losing its outer layers to the monster's gravity. The infalling matter forms a swirling accretion disk, glowing hotter and hotter as it spirals inward until it releases torrents of X-rays before disappearing beyond the event horizon. These systems, though tiny compared to the galaxy itself, are among the most powerful engines of energy known. They are cosmic theaters of destruction and creation, where gravity, motion, and light converge in a single, breathtaking act. Observing them helps scientists understand not only how black holes feed and evolve but also how their immense energies ripple outward, shaping entire regions of space. Throughout its history, Andromeda has undergone periods of intense transformation. Its star formation has not been constant but rather cyclical, alternating between calm and chaos. Over billions of years, waves of star birth have swept through its spiral arms, triggered by gravitational interactions with neighboring galaxies that compressed clouds of hydrogen gas and ignited cascades of new suns. These epochs of creation filled Andromeda's arms with clusters of hot, blue stars whose brilliance illuminated the galaxy's spiral structure. Between these bursts, quieter intervals followed, allowing the gas to cool and the galaxy to rest before the next wave of creation began. This rhythmic breathing of activity and stillness forms the natural heartbeat of a galaxy, an eternal cycle of renewal that mirrors the cosmic balance of energy and entropy. The evidence of these past starbursts is written across Andromeda's structure, visible in the color gradients of its arms and the ages of its stellar populations. Each generation of stars contributes to the next, enriching the galaxy with heavier elements and creating the materials needed for planets, atmospheres, and life. Thus, Andromeda is not a static island of stars but a living, evolving system shaped by forces both visible and unseen. Its globular clusters tell of ancient beginnings. Its magnetic field whispers of invisible order. Its gamma-ray glow hints at dark matter secrets. And its X-ray light reveals the ongoing dance of death and rebirth that defines every galaxy. Across its vast span, hundreds of thousands of light-years wide, every particle, photon, and atom participates in a grand, unending interplay. From the densest star cluster to the faintest drifting gas cloud, all are connected through gravity, magnetism, and time. In Andromeda, we see not merely a neighboring galaxy, but a reflection of our own Milky Way's fate and of the universe's ceaseless drive toward transformation. It is a reminder that the cosmos, for all its stillness and silence, is alive with motion, memory, and mystery, a story written in light across the endless dark. Each generation of stars within the Andromeda Galaxy carries the memory of ancient cosmic bursts that once illuminated the universe, reminders of the galaxy's ceaseless vitality and transformation. These bursts were often set in motion by immense cosmic events, most notably, the collisions and mergers of galaxies. Galaxies do not drift through the cosmos in isolation. Instead, they are participants in a vast gravitational dance, constantly interacting, merging, and reshaping one another over timescales stretching across billions of years. Throughout Andromeda's history, countless smaller galaxies have likely collided with it or passed close enough for their gravitational forces to compress gas and dust, igniting colossal waves of star formation that ripple through the galactic disk. These cosmic interactions are preserved as visible imprints in the warped contours of Andromeda's spiral arms, in the subtle distortions of its disk, and in the delicate, ghost-like streams of stars that stretch far beyond its visible boundaries. Each of these encounters, though destructive in the moment, ultimately contributed to the galaxy's renewal, supplying it with fresh material and energy that enabled it to grow into the majestic spiral we see today. Every star twinkling within its luminous arms may owe its existence to one of these ancient mergers, each collision a silent yet powerful act of cosmic creation that shaped the galaxy across the eons. Beyond its brilliant disk lies Andromeda's vast and faint stellar halo, a sprawling, nearly invisible sphere filled with remnants of those ancient collisions. Here, faint arcs and wisps of stars trace the ghostly paths of long-vanished galaxies that were torn apart and absorbed into Andromeda's greater whole. Though barely perceptible to the naked eye, modern telescopes and sensitive instruments reveal these streams as faint fingerprints upon the canvas of space, each one preserving the story of a merger that occurred billions of years ago when the universe itself was still young. By examining their shapes, chemical compositions, and orbital motions, astronomers have been able to reconstruct Andromeda's evolutionary timeline, unraveling how its mass and structure have been sculpted by countless interactions. The halo, though dim and diffuse, is alive with memory. Every solitary star drifting through it represents a fragment of ancient history, a relic of the collisions and assimilations that gradually built one of the most magnificent galaxies in our cosmic neighborhood. Surrounding the main body of Andromeda are thread-like stellar streams that extend for hundreds of thousands of light-years into space, ethereal trails formed from the scattered remains of smaller galaxies that once orbited the giant spiral before being torn apart by its gravity. These stellar streams act like a fossil record of cosmic history, their shimmering trails preserving evidence of events that unfolded billions of years ago. By tracing their positions and velocities, scientists can reconstruct the sequence of Andromeda's mergers much as archaeologists study ruins to piece together the rise and fall of ancient civilizations. The story they tell is one of endless renewal. Galaxies grow by consuming others, recycling their stars and gas in a continuous process that has no true beginning or end. In the faint light of these stellar streams lies the memory of creation itself, a cosmic narrative written across the quiet outskirts of a galaxy still gathering itself from the dust of its past. For centuries, astronomers believed that Andromeda's visible disk represented the full extent of its domain. But modern observations have revealed that its stellar halo extends far beyond what the human eye, or even early telescopes, could detect, stretching nearly halfway toward our own Milky Way. This immense halo contains a rich mixture of elements, faint stars, glowing clouds of hot gas, globular clusters that orbit like ancient beacons, and ghostly stellar streams that weave through the darkness. The discovery of this colossal structure has reshaped our understanding of what defines a galaxy's true size and influence. Andromeda, it turns out, is not merely a bright spiral in the sky, it is an enormous gravitational structure that dominates a vast region of the local group. Within this halo exists a remarkable diversity of stars, some ancient, dating back to the earliest epochs of galaxy formation, and others much younger, having been stripped from smaller galaxies that recently merged with Andromeda. This mixture of ages reveals that the halo is dynamic, ever-changing, and constantly renewed. New stars are added as galaxies interact and merge, while old ones drift outward over time, forming a seamless gradient from the bright disk to the dim intergalactic frontier. The halo thus serves both as a museum and a construction site, preserving relics of the distant past while incorporating new material into its evolving structure. Every star within it contributes a thread to Andromeda's ongoing story, each one helping astronomers piece together how galaxies assemble their mass and grow over cosmic time. As the halo stretches outward, it merges almost imperceptibly with the intergalactic medium, blending into the vast expanse between galaxies. There is no sharp boundary, no visible line where Andromeda ends and the universe begins. Instead, its stars and gas gradually fade into the cosmic background, demonstrating that galaxies are not isolated islands, but interconnected nodes within the immense cosmic web that spans the universe. In this outermost region, Andromeda's gravitational influence weakens, giving way to the subtle tug of the universe at large. Here, stray stars and drifting clusters wander freely, either fully bound to Andromeda nor entirely part of intergalactic space. Observing this quiet frontier allows astronomers to glimpse the intimate relationship between galaxies and the larger structures they inhabit, a gentle reminder that everything in the cosmos is connected. Among the countless stars populating Andromeda's halo, many are ancient beyond imagination, older than our Sun by billions of years. Some formed more than 10 billion years ago, during an era when the universe was still in its youth and heavy elements were rare. These primordial suns have burned slowly across the ages, their light steady and unchanging while entire civilizations have risen and fallen on distant worlds. By studying their compositions, astronomers can infer the conditions that existed near the dawn of time. These stars contain very few heavy elements such as iron or carbon, indicating they were born before earlier generations of stars had enriched the universe with the byproducts of nuclear fusion. Thus, they serve as cosmic time capsules, preserving within their light the record of the earliest chemical and physical processes that gave rise to all later generations of stars. Yet Andromeda is not a relic of the past alone, it remains a site of active creation. In its spiral arms and diffuse gas clouds, new stars continue to form even now. Within luminous nebulae scattered across the galactic disk, gravity draws together cold hydrogen gas into dense knots that collapse and ignite, giving birth to newborn suns. These young stars illuminate their surroundings, causing nearby clouds to glow with hues of pink, red, and gold. Some of these stars are massive and short-lived, destined to end their lives in brilliant supernova explosions, while others resemble our Sun and may endure for billions of years. This coexistence of the old and the new tells the story of an unbroken cycle, a rhythm of creation and destruction that has continued since the galaxy first came into being. Each new star carries within it the recycled material of countless predecessors, proving that even in a universe more than 13 billion years old, creation is not finished. The elements that compose these stars, hydrogen, helium, carbon, oxygen, iron, and even gold, tell a tale of gradual enrichment. The oldest stars consist almost entirely of the simplest elements born in the Big Bang, while younger ones bear the fingerprints of generations of stellar alchemy, forged in the hearts of ancient suns and scattered by their explosive deaths. Over time, this ongoing cycle has filled Andromeda with the complex chemistry needed to form planets, life, and perhaps even future civilizations. In this way, the galaxy stands as both a monument to cosmic history and a cradle of continuing creation, a vast, ever-evolving system where destruction gives rise to renewal, and the light of ancient stars mingles with the glow of the newborn. From its luminous spiral arms to its faint, whispering halo, Andromeda tells the story of the universe itself, a story of endless transformation, memory, and motion written across the boundless night of time. By analyzing the light emitted by Andromeda's countless stars, astronomers have been able to reconstruct a detailed record of the galaxy's long chemical evolution, tracing its transformation from a primordial swirl of simple hydrogen and helium gas into a rich and complex environment capable of forming planets, and perhaps even life. Each spectral line in the starlight acts like a historical fingerprint, revealing the abundance of different elements and the processes that forged them. In this way, Andromeda's chemistry serves as both a timeline and a testament to the endless cycle of renewal that drives the cosmos. Every generation of stars has played its part in enriching the galaxy's material composition, seeding the next with heavier and more complex elements. When massive stars reach the end of their lifespans, they explode in brilliant supernovae, scattering their enriched contents, carbon, oxygen, iron, and gold, into the vast interstellar medium. The gas and dust released by these explosions mix with surrounding material, cooling and condensing into new molecular clouds from which fresh stars and planets are born. With each cycle of stellar birth and death, Andromeda's overall composition becomes more intricate and diverse, a cosmic alchemy that has unfolded over billions of years. This ongoing transformation has turned simple hydrogen into the building blocks of life itself, forging the oxygen we breathe, the carbon in our bodies, and the iron in our blood. The light that shimmers across Andromeda's majestic spiral arms is therefore more than the glow of distant suns. It is living evidence of a continuous cycle of creation and renewal that has shaped the galaxy since its birth. Andromeda functions as a vast, celestial alchemist, forever transmuting the simple into the complex, forging within its countless stars the ingredients necessary for life and scattering them across space in an eternal rhythm of destruction and rebirth. As stars form from the enriched gas of previous generations, the planets that coalesce around them inherit these same life-giving elements. Many of Andromeda's planetary systems likely contain rocky worlds with metallic cores and atmospheres rich in carbon-based molecules, perhaps even with oceans, weather, and geological activity similar to Earth's. Some of these distant planets might possess volcanic moons, icy rings, or thick atmospheres composed of water vapor, carbon dioxide, or methane. The presence of these elements throughout the galaxy suggests that the chemical conditions necessary for complex chemistry, and possibly even life, may be widespread. Though we cannot yet directly observe these alien worlds, the light from their parent stars carries subtle signatures of the elements and compounds that shape them, offering tantalizing clues about their composition. In this way, Andromeda mirrors our own Milky Way. Both are immense star cities filled with billions of suns, each surrounded by worlds that represent quiet possibilities scattered across the cosmic ocean. Every planetary system, hidden within the glittering expanse of Andromeda, is a potential harbor of complexity, waiting to be discovered across the great gulf of intergalactic space. Despite appearing steady and constant to the naked eye, Andromeda's brightness subtly varies over time. Sensitive measurements reveal that its glow changes slightly over decades and centuries, a delicate pulsation caused by the rise and fall of star formation, the explosion of supernovae, and the motion of interstellar dust clouds that scatter and absorb light. Some regions of the galaxy grow brighter as clusters of young, luminous stars ignite, while others fade as massive stars exhaust their fuel and die. Even the shifting patterns of dust and gas drifting through the spiral arms can cause small fluctuations in its apparent brightness. These variations remind us that a galaxy is not a static or lifeless structure but a dynamic, evolving system, breathing slowly through cycles of creation and decline. Observing these changes allows astronomers to track Andromeda's ongoing evolution, to watch, in slow motion, as the galaxy pulses with the rhythm of star birth and death. Its steady yet ever-changing light becomes a kind of cosmic heartbeat, visible across the vastness of time and space, a gentle reminder that even the most distant objects in the universe are alive with motion and transformation. This subtle heartbeat reflects the natural rhythm of star formation cycles that give Andromeda its vitality. Across its immense spiral disk, waves of gas collapse under gravity to form clusters of newborn stars, which blaze brightly for a time before fading as the material is used up or blown away by powerful stellar winds. These alternating periods of brightness and dimming repeat over millions of years, giving the galaxy a slow, majestic pulse, a rhythm not of seconds but of eras. To observe such changes is to sense a kind of cosmic breath, as if the universe itself were inhaling and exhaling light, creating and resting in a balance as timeless as gravity. Andromeda's very rotation contributes to this living dynamism. The galaxy turns gracefully through space, though its motion is far too slow for any eye to perceive directly. Astronomers have detected this rotation by studying the Doppler shifts in its light. One side of the galaxy appears slightly bluer because it is moving toward us, while the other side appears slightly redder as it moves away. These subtle changes reveal that Andromeda's billions of stars orbit a common center, held together by gravity and anchored by a supermassive black hole. Every point of light we see is part of this grand movement, a fragment of a vast celestial wheel that turns with perfect, unhurried precision. It takes hundreds of millions of years for Andromeda to complete a single rotation, a timescale so vast that entire species could rise and vanish on distant worlds before the galaxy finishes one turn. Yet, through all this, the pattern remains steady and harmonious. Each star, cloud, and cluster follows its own orbit, yet together they create the magnificent spiral we see from afar. Gravity pulls inward, Motion pushes outward, and between these forces lies a perfect balance that has persisted for billions of years. To imagine this colossal wheel slowly turning in the darkness is to glimpse the deeper rhythm of the cosmos, a universe where time stretches beyond human comprehension, and where patience itself becomes a kind of beauty. The galaxy's motion is not hurried, but certain. Each rotation carries within it the memory of billions of suns that have lived, shone, and returned their essence to the interstellar sea from which new generations arise. Even as its stars move endlessly through space, Andromeda's spiral pattern has remained remarkably stable over cosmic timescales. Though it might seem that the arms are solid lines of stars, they are actually waves of density, ripples moving through the disk like waves on water. As these density waves pass through regions of gas and dust, they compress the material, triggering bursts of star formation. When the wave moves on, those regions fade as their bright young stars age and die, while new clusters ignite elsewhere. Yet the pattern endures, maintaining its elegant form through the interplay of gravity, motion, and the flow of interstellar gas. This dynamic equilibrium has allowed Andromeda to sustain its delicate spiral shape for billions of years, even as individual stars come and go. To behold the galaxy's spiral is to witness order emerging from motion, a self-sustaining harmony within a universe defined by constant change. These luminous arms are not merely features of light, they are echoes of timeless forces, visible expressions of the invisible mathematics that governs the structure of creation itself. Nestled beneath the bright expanse of Andromeda's disk lies a smaller, intriguing companion galaxy known as Messier 32. Appearing as a compact, oval glow, Messier 32 is dense and smooth, containing only a fraction of Andromeda's stars yet shining with its own quiet brilliance. It is composed mostly of ancient suns packed tightly together, forming a spherical core that contrasts sharply with the sprawling spiral of its massive neighbor. Astronomers believe that Messier 32 once had outer layers that were stripped away by Andromeda's immense gravity during close encounters in the distant past. These interactions may have shaped both galaxies, subtly warping Andromeda's disk and influencing its rotation, while leaving Messier 32 as a bare remnant of its former self. This relationship between the two galaxies illustrates the intricate gravitational choreography that defines galactic evolution. Even in the apparent stillness of the night sky, immense forces are at work, stretching, twisting, and reshaping entire systems over eons. Together, Andromeda and Messier 32 stand as living examples of how galaxies grow and transform through interaction, bound by gravity in a silent, endless dance that continues to shape the structure of the universe itself. In this grand picture, Andromeda is not merely a distant object of beauty, it is a cosmic record, an ongoing experiment in creation and transformation. Through its chemistry, its cycles of light and shadow, its rotation, and its graceful arms, the galaxy tells the story of matter evolving from simplicity to complexity, of energy flowing endlessly through time, and of stars forging the very elements that make life possible. Every photon that reaches us from Andromeda carries the memory of that process, a whisper from the past reminding us that we, too, are part of this same story, made from the same stardust that burns in its distant suns. Today, Messier 32 orbits as a loyal companion to the Andromeda Galaxy, forever bound by the gravitational embrace of its vast spiral neighbor. Though small in comparison, it plays an essential role in the grand story of galactic evolution, serving as a living reminder that even the tiniest of celestial bodies contribute to the beauty and complexity of the cosmos. Its soft, elliptical glow, compact and serene, speaks of the quiet companionship that exists between galaxies, an unspoken dialogue of light and gravity. Alongside it drifts another companion, Messier 110, a larger elliptical galaxy that moves gracefully through Andromeda's immense gravitational field. Though fainter and more diffuse than Andromeda, it carries the aged light of ancient stars whose fiery youth has long passed. Much of its gas and dust has been stripped away by Andromeda's powerful pull, leaving behind a red-tinged sphere of stellar embers. Over the course of billions of years, it too will likely merge with Andromeda, its stars absorbed into the greater whole, becoming one with the luminous heart of its vast companion. These smaller galaxies, Messier 32 and Messier 110, are not mere satellites, but participants in the cosmic dance that defines galactic evolution. Their slow, spiraling orbits subtly reshape their forms and histories, and astronomers study these interactions to understand how galaxies grow, merge, and exchange their substance across eternity. Each orbit, each gravitational encounter, becomes a brushstroke in the ongoing masterpiece of creation. Messier 110, glowing faintly like an ember beside a great fire, drifts ever closer to its destiny. Over time, its slow inward spiral toward Andromeda will mark the inevitable unity of two once separate systems. These small galaxies are drawn irresistibly inward by Andromeda's immense gravitational power. Their orbits decay across countless ages, until they are finally absorbed into the greater spiral, a process so gradual that it unfolds over billions of years, leaving faint streams of stars as their final testimony. These trails of light, like ghostly rivers winding through Andromeda's halo, are the remnants of galaxies long since merged and transformed. Each merger adds new stars, new dust, and new stories to Andromeda's expanding body, enriching its history and altering its future. It is through such delicate collisions that galaxies renew themselves, transforming separation into unity, loss into creation. The companions of Andromeda are already following this path, their fates written in the slow, inevitable language of motion. In their journey we see the profound truth that in the universe, endings are merely beginnings wearing new forms of light. Even now, the gravitational tides between Andromeda and its companions distort their shapes. Once rounded galaxies appear stretched, their stars pulled into thin streams by the vast pull of Andromeda's mass. These streams, too faint for the naked eye but visible through powerful telescopes, form intricate patterns that lace Andromeda's halo. Each shimmering thread marks a chapter in the story of galactic interaction, a record of the unseen forces shaping the cosmos. Astronomers use these subtle distortions to study Andromeda's hidden structure, the immense dark matter halo that surrounds it. Though invisible, dark matter reveals itself through its gravitational effects, bending the motions of stars and galaxies alike. In every faintly warped companion, every stretched river of stars, we see the fingerprint of this invisible architecture. What might appear as destruction is, in truth, a slow transformation, the universe reshaping itself according to the timeless laws of gravity, creating harmony from chaos with quiet beauty. Andromeda itself belongs to a greater celestial family known as the Local Group, a vast assembly of more than 50 galaxies bound together by gravity. This cluster includes everything from great spirals like the Milky Way and Andromeda to tiny, dim dwarfs scattered throughout the surrounding space. Though separated by millions of light years, all members of the Local Group move in a delicate gravitational balance, orbiting a shared center of mass and drifting together through the cosmic void. Within this grand structure, galaxies interact, merge, and exchange material, influencing one another's destinies through the silent pull of gravity. Andromeda, being the largest, dominates this family, its influence extending far beyond its visible edges. Yet it is not a ruler but a participant in a cosmic community, a celestial neighborhood where galaxies coexist, evolve, and shape one another in endless cycles. The Milky Way, our own home galaxy, is Andromeda's twin in this group. Together, they are the giants of the Local Group, surrounded by a retinue of smaller galaxies that orbit them in intricate patterns. Some are irregular clouds of stars and gas, while others are tight, spherical clusters of ancient suns. These dwarfs are the cosmic seeds from which larger galaxies have grown, and though small, they are essential to understanding the evolution of galactic structures. Their orbits, spanning billions of years, trace graceful arcs through space, occasionally bringing them close enough to their massive companions to be torn apart and assimilated. The halos of Andromeda and the Milky Way bear the evidence of countless such mergers, stellar fossils of galaxies that long ago surrendered their light to greater systems. Observing these processes gives astronomers insight into the universal balance of attraction and motion, a balance that governs everything from the dance of atoms to the orbits of galaxies. The members of the Local Group, including Andromeda and the Milky Way, orbit a common gravitational center, a point not marked by light but by balance itself. This center represents the combined mass of all its members, a delicate equilibrium of cosmic forces. Neither of the great spirals sits precisely at this center. Instead, Each moves around it in an immense, stately orbit, carrying its companions along like dancers moving in rhythm around an invisible stage. To imagine this motion is to picture a vast, celestial ballet, each galaxy tracing its own path, yet all bound together by the same silent conductor, gravity. This shared motion demonstrates the deep unity of the cosmos. Every orbit, no matter how long or slow, obeys the same natural law, the same pull that binds planets to stars and stars to galaxies. In this way, the local group becomes a living embodiment of the universe's harmony, a dance of matter and motion unfolding across space and time. Yet even this grand structure is not fixed. The local group itself drifts toward an even larger congregation of galaxies known as the Virgo cluster. This slow, majestic movement is part of the cosmic flow, the vast, invisible current of matter that weaves through the universe like an eternal tide. The local group's journey toward Virgo spans billions of years, a silent pilgrimage through the cosmic web that connects all things. Though imperceptible to human senses, astronomers can measure this motion with great precision, revealing that nothing in the universe stands still. Every cluster, every galaxy, every particle of matter participates in this immense migration, drawn by gravity toward regions of greater density in the endless expansion of space. Our entire galactic neighborhood drifts like a leaf on an invisible river, carried by forces both gentle and immense. Beyond the local group lies the Virgo supercluster, a colossal structure stretching over 100 million light-years and containing thousands of galaxies. It forms one of the major filaments of the cosmic web, the great scaffolding of matter that defines the shape of the observable universe. Within it, clusters and groups like our own gather into massive patterns that extend farther than the eye or telescope can see. At its heart lies the Virgo cluster, a radiant congregation of galaxies glowing with the combined light of countless stars. The local group, with Andromeda and the Milky Way at its core, lies at the edge of this supercluster, slowly drifting inward, drawn by gravity's unending call. The Virgo supercluster is not an isolated island but part of an even larger tapestry, a network of interconnected structures that link all matter across unimaginable distances. Every galaxy, every star, every atom participates in this grand cosmic architecture. To contemplate the Virgo supercluster is to confront the immensity of existence itself, where even entire galaxies appear as mere points of light in a boundless ocean of space. And yet, within this vastness, the Andromeda Galaxy and the Milky Way stand as two brilliant beacons, bright, spiraling cities of stars that illuminate our corner of the cosmos. From Andromeda's vantage point, the Milky Way would appear much as we see Andromeda, a radiant spiral of light, surrounded by faint companions, shining softly against the black sea of eternity. Together, they remind us that the universe, for all its incomprehensible scale, is a single, interconnected whole, a living web of matter and energy, woven by the silent hands of gravity and time, where every motion, every spark, and every star contributes to the eternal story of creation. The two galaxies are bound together by the invisible force of mutual gravity, slowly drawing closer across the vast emptiness of space. Their shared radiance casts a gentle glow across our region of the universe, acting as twin beacons for distant civilizations that might one day gaze in our direction. Together, they form the twin anchors of the local group, balancing its gravitational dance and defining its structure. In their slow, inevitable approach, they embody both symmetry and destiny, for their motion will ultimately unite them into one grand creation. Within their light, we see the beauty of cosmic motion, two spirals gliding toward each other through the ages, weaving a celestial story that stretches beyond imagination. Studying Andromeda gives astronomers an extraordinary opportunity to understand how galaxies form, evolve, and transform over billions of years. Because it lies relatively close to us, Andromeda allows scientists to trace the entire arc of a galaxy's life in remarkable detail. Every star within it is like a page from a cosmic diary, revealing clues about its formation, its changing structure, and the processes that drive galaxy evolution across the universe. By comparing Andromeda's intricate spiral arms, its vast halo, and its vibrant star-forming regions to those of our Milky Way, astronomers uncover echoes of shared history. Every new discovery in Andromeda reflects something about ourselves, revealing how galaxies recycle their material through generations of stars, how matter, energy, and time are constantly renewed in a cycle of birth and death. It provides not just a glimpse of what has been, but also what will be, a living example of cosmic evolution unfolding before our eyes. In its luminous arms, we can read patterns that apply to all galaxies, from the smallest dwarfs shimmering faintly at the edge of the cosmos to the grandest clusters glowing with thousands of suns. To study Andromeda is not merely to observe, it is to participate in a shared universal story written in the glowing language of starlight. For Andromeda is more than a neighboring galaxy, it is a mirror, reflecting our own future. Over the next 4 billion years, gravity will gently draw Andromeda and the Milky Way together in a slow, graceful dance of merging. When that distant time comes, the night sky of any surviving planet will blaze with light as the two galaxies intertwine, their shapes distorting into new and beautiful forms. Yet, despite their collision, stars themselves will almost never meet, for the distances between them are unimaginably vast. Instead, their orbits will shift, weaving new patterns of celestial architecture. The end result will be a single, massive elliptical galaxy that will shine brighter than either of its predecessors, a monument to cosmic transformation rather than destruction. This future union reminds us that even in the vast silence of space, change is both gentle and inevitable, a constant rebirth written in the motion of galaxies. In the glow of Andromeda, we can almost read our destiny across the heavens, written in light billions of years old. Each new generation of telescopes has revealed more of Andromeda's secrets. From the earliest refracting lenses of the 17th century to the vast space observatories orbiting Earth today, our instruments have brought this majestic galaxy into ever sharper focus. What once appeared as a faint smudge of light in the night sky now reveals swirling arms of dust and gas, radiant clusters of young blue stars, and ancient red giants scattered through its halo. Modern astronomers study Andromeda across the entire electromagnetic spectrum: radio waves, infrared light, ultraviolet, X-rays, each wavelength peeling back a new layer of structure and energy. Every technological advance deepens our understanding and expands our wonder. The more precisely we see, the more mystery we uncover, as if the galaxy itself grows richer and more intricate with every gaze. Andromeda is a reminder that knowledge and curiosity are endless companions, that discovery itself is a journey without end. As our tools evolve, so too does our connection to this great cosmic neighbor, whose light continues to reach us, unchanged, from millions of years ago. Even amateur astronomers, standing quietly in their backyards, can photograph it from Earth. Despite its enormous distance, over 2.5 million light-years away, the Andromeda Galaxy is bright enough to be seen without a telescope under a dark, moonless sky. Through binoculars or a small telescope, it appears as a delicate, elongated glow, with a soft central bulge surrounded by faint spiraling arms. Around the world, amateur sky watchers capture its image by stacking long-exposure photographs, each layer revealing a little more of its hidden beauty. Every one of those images records light that began its journey long before human civilization existed, light that has crossed intergalactic space for millions of years to finally touch the surface of a camera sensor or an open human eye. That act of witnessing connects us directly to the grand structure of the cosmos. Andromeda becomes a symbol of wonder within reach, a bridge between the familiar world beneath our feet and the infinity stretching beyond it. For those who look up from a quiet backyard, the faint shimmer of the galaxy becomes a silent companion, whispering stories of creation and time in a language made of light. When we gaze upon Andromeda, we are not merely observing a distant object, we are seeing the past itself. The photons entering our eyes tonight began their journey before humans even walked the Earth, carrying with them the memory of ancient suns, of galaxies colliding and stars being born. In every particle of that light is written the slow, patient rhythm of the universe, the birth and death of stars, the rise and fall of galaxies, the breathing of cosmic time itself. Each time its light reaches Earth, it is as though the universe is reminding us that we are part of something far older and far grander than we can comprehend. The Andromeda Galaxy stands not only as a celestial landmark but as a symbol of the universe's eternal process of becoming. Within its majestic spiral arms, New stars ignite in the cradles of gas and dust even as others fade away. Whole solar systems rise and dissolve, nebulae flare into radiance and drift apart, and the cycle continues endlessly. Watching Andromeda is like watching the cosmos breathe, slow, steady, eternal. Each photon that reaches us carries a trace of that story, an imprint of cosmic creation still unfolding. The universe, as Andromeda teaches us, never rests. It creates, transforms, and renews itself endlessly. Its message is simple yet profound. Existence itself is motion, and all things are bound together by the flow of energy, time, and gravity. To gaze upon Andromeda is to witness creation still in progress, to look upon an unbroken story that stretches back to the dawn of time and forward into eternity. It is both a lesson and a promise that the universe is still becoming, and that we are a part of its slow, graceful unfolding. As Andromeda's light fades from your thoughts, imagine drifting with it into the quiet stillness of intergalactic space. Beyond the Milky Way, beyond the reach of any single star, the darkness becomes soft and luminous with the glow of countless galaxies scattered like dust across the cosmic sea. There, everything moves in serene harmony. The stars are silent, yet their light hums softly in the mind, a reminder that even amid vast emptiness there is peace. The universe does not rush. It expands and evolves with patience, with purpose, with grace. Stars are born in calm clouds of gas, galaxies turn with quiet majesty, and time itself flows like a slow tide across the infinite shore of being. You, too, are part of that rhythm, a fleeting spark in the long story of light. The atoms that make up your body once drifted through ancient stars like those shining now in Andromeda. Their energy burns within you still, a living echo of the same fire that ignites galaxies. Let your breath follow that cosmic rhythm, slow and steady. Let your thoughts settle into the silence between the stars. The universe asks nothing of you but rest. Its beauty is enough. Its motion continues whether your eyes are open or closed. Somewhere far away, the light of Andromeda is still crossing the void, bearing the same calm radiance it has carried for millions of years. By the time that light reaches our world, you will be far away in dreams, floating peacefully among the stars that gave you life, resting beneath the endless night of the universe itself.